Okay, so first let's talk about who is AdaCore. For those of you who are not familiar with who we are and what we do, as you can see in the name here, we focus on the Ada programming language. So we develop compilers and tools associated around the Ada programming language. We also do tools related to C and C++, because as you might be aware, many applications where you're using Ada, you could also be using C and C++. And for those doing modeling, we also do a bit of work with the Simulink tools where we can generate source code. I'll cover in detail the tools that you can use with these languages as we go through the presentation. So AdaCore was founded in the mid-90s. The reason why the company started was to do an open source version of a Ada compiler. So the GNATPro Toolsuite, which is our compiler, is based on open source GCC technology. This is nice because it allows us to leverage a lot of work that's done by the community. A lot of this work is testing of the tools, and the tools have a legacy from all that testing. So we're able to build on top of stable technology. A lot of our projects that we work on are in the safety and security critical industries. So this is military, avionics, railroad, space. And because of this, these many years of work within the Ada toolset, we are the experts in Ada. We actually contribute to the design of the Ada language. As you might be aware, there was an Ada 2012 version of the language, and they're currently working on the next version of the language, which should come out in the 2020s. We also work directly with a lot of certification industries so that we're aware of all the challenges you have as developers so that we can help you go through these certifications. So the tools that we actually offer, as I mentioned, we focus in on the Ada language. We also work with the integration of C and C++ and Simulink. So we've developed a comprehensive tool set that allows you to develop your applications and go through all of the process of the development lifecycle so that you can go and do your Ada applications. So we do have native and cross compilers. We have IDEs. These are going to be modern IDEs where you can do a lot of fancy work that you're used to with other modern IDEs, and we'll see an example of this in the demo. And we also integrate in with the GDB debugger. To aid in your development, we also have static analysis and verification tools. The first one listed here is CodePeer. We're going to talk a bit about that later, and we'll actually cover that in detail in a webinar next week. We'll send out details via email about that webinar. We have a tool called GNAT Coverage. We can do dynamic analysis of code. We can check for coding standards, and we can do even formal verification with what's called Spark. We'll go through a bit more about that later. For those doing modeling, we do have tools for modeling. We're not going to cover those today, but if you do have questions, do send your questions in the QA box. We'll follow up via email. So let's talk about GNATPro. GNATPro is a tool suite. It includes a compiler, a full tool chain, so compiler, debugger, assembler, all those things. These could be native or cross tools. It includes an IDE, full development environment with all of these tools I mentioned earlier to do coding standard verifications and basic static analysis, things like that. This is all integrated into a single environment. The most important thing about the GNATPro tool suite is that the compilers are based on GCC. So as I mentioned, this is a long-running project that has support for many architectures and operating systems. So we can leverage that to make sure we have compilers for all of the architectures and all of the real-time operating systems that you are currently using in your applications. Here's an example of some of the targets that we do support. You'll notice that we have a fairly comprehensive support for the VxWorks product. This is Wind River's VxWorks real-time operating system. They're one of our partners, as well as PikeOS and LynxOS. We work with them as operating system suppliers to make sure we can develop the Ada runtime for these specific operating systems. So if you already have these operating systems in your hardware or are looking to take these types of operating systems and bring them into your future projects, we have support for these architectures. You might also be doing some bare metal development. This would be the case where you're writing software directly on the hardware without a real-time operating system. As you can see here, we have fairly comprehensive support for legacy and modern processors. You can see at the bottom there that we are supporting the RISC-V chipset. This is a instruction set that was developed to be open source. So this is the new processor architecture being used for many development applications that are looking at modern hardware. We, of course, support 32 and 64-bit ARM, as well as legacy PowerPC products. We also support a native development as well, Windows, Linux, Mac OS. We typically have customers who are deploying on hardware, but they want to do their tests on native. So in many applications, developers use the native products to do their testing and development, and then use our cross tools to deploy their software on the architecture. So before I mentioned that AdaCore is directly contributing to the Ada language specification. So for those not familiar with Ada 2012, this is the newest version of the language. Again, I mentioned there is a new version being worked on right now. It's going to be released in the next few years. So for now, let's talk about Ada 2012. What's nice about Ada 2012 is that it's mostly backwards compatible with older versions of Ada. In many cases, if you have an Ada 95 or Ada 83 application, you can use an Ada 2012 compiler to compile that because of this backwards incompatibility. There's only a few different things that have been added. For instance, there's a change in how some limited types work, and there's a one or two more reserved words. But in most cases, most applications are ready to be compiled with Ada 2012. And you'll notice no functional difference if you compile it with an Ada 2012 compiler. What's nice, though, is you have access to a bunch of new features within Ada 2012. So for instance, this concept of contracts. We're used to, as Ada developers, for those who are Ada developers, you might be aware of contracts on types. This would be like a range on a type. The compiler inserts some checks to make sure that the values going into that variable fit within the range. We can do something similar with these contracts on subprograms, where we're actually taking the compiler and having it check the functionality of a specific subprogram. So in this first example here, procedure P takes two variables, x and y, and the compiler will insert a check, let's say a defensive check, to make sure that x plus y is greater than 0 before the subprogram is called. This is kind of nice because typically you'd write this sort of logic in your in a defensive check at the top of the subprogram. So here we're actually going to allow the compiler to help us check to make sure that our inputs are correct before we actually run the subprogram. We can do the same thing here with a post condition, which allows us to make sure that the implementation of the subprogram follows our specifications. So here, let's say I'm writing a specification for a subprogram, and I want to make sure that some global G is incremented by 1 in the implementation. Then I'm going to pass that specification off to another group who's going to do the implementation. What we can do now is we can make sure at runtime, or with a static analysis tool, we can check this statically, that the implementation that was done by one group matches the specification, which is done by another group. And again, these things are inserted automatically by the compiler and can be checked at runtime. Or with static analysis tools, we can check this statically. So I do have a question here. Someone's asking if this presentation will be available online afterwards. The answer is yes. So we will have a recording of this that we will send out. A couple other things that are sort of new in the Ada 2012 language. We can actually take contracts on types a little bit farther than we normally would with a range type. So you can see here we have this thing we're calling a dynamic predicate, where we're saying that type even is a new integer with some dynamic predicate. So what this is saying is that every time we have a variable of type even, the compiler will check to make sure that the value being inserted into that variable mod2 equals 0. So this is kind of an interesting way to check to make sure we only store, let's say, even values inside the variable. We can also do these things called quantifiers here. You can see that the sorted array is a type of array with integers, and every time we change this array, we're actually going to run this loop. So this is actually checking to make sure this loop the array is always sorted every time we modify it. This is an example of a very complicated thing you can do with Ada 2012. This isn't necessarily something you want to run at runtime. For instance, every time you modify a variable of type sorted array, it's going to run this loop. So that's a lot of code that's going to be added. But what's nice is if you are using static analysis techniques, you can actually write all this in here, check to make sure that everything is valid statically, and then remove these sorts of compiler inserted checks during the compilation, so that you don't have the runtime checks, but you kind of prove to make sure that they aren't necessary statically. So with Ada 2012, we insert all these runtime checks that we can or we don't have to include in the final binary. And then with Spark, which is a formal verification static analysis tool, we can actually prove a lot of these types of checks completely statically. We'll talk a little bit more about Spark shortly. So I mentioned earlier that we do specialize in Ada, but we also do a lot of work with C and C++. As I mentioned, we're based on GCC. So GCC allows us to have a lot of different compiler backends. So for instance, what we do on GCC is we provide an Ada front end, which does all of the Ada translation to the GCC tree, and then that is converted into machine code. So we already have all of this infrastructure that's supplied by GCC that allows us to also do C and C++ work. And because we've been contributing to the GCC platform since the 90s, we are experts in this compiler technology. So in Ada, C, and C++, we can provide completely expert support. And what's nice is if you have an application, which is a mixed language application, where you're using Ada, C, and C++ in the same binary, a lot of times those edges where one language transitions to the other can be a little bit complicated. And this is where you're going to want a compiler vendor to help you out on both sides of the languages, both Ada and C or Ada and C++. We have support for C and C++ on most of the platforms I mentioned earlier. So if you do have an application where you're using these languages, we can support you. So you might be thinking, why AdaCore and C and C++? Because typically, you might have an application like this, where you have Ada on top of an OS, RTOS, or you're basically on the metal. But a lot of times you're actually going to have this, where you have Ada, C, and C++ on top of the OS and RTOS. You might even only have the C and C++ on top of the OS and RTOS. And then you're thinking, well, I already have C and C++ from the OS or from the RTOS or bare metal. Why should I go with AdaCore? We kind of already understand why this is interesting, because as I mentioned earlier, the boundaries between languages can be challenging, and this is where AdaCore can help you with its expertise. But if you're only doing C and C++, why use AdaCore? Well, let's talk a little bit more about the integration of languages here. So in a lot of applications, you have this. You have C, Ada, and C++, as I mentioned earlier. That gets passed to GCC, and we have a binary that gets output. GCC is based on open source technology. We're probably all pretty familiar with GCC at this point. But a lot of times you might have something like this, where your C and C++ come from a different vendor than the Ada. So for instance, the C and C++ is provided by an OS or RTOS, and then the Ada is provided by AdaCore. Typically, you'd use the C and C++ from the OS because it comes with the operating system. I don't need to get it from a vendor. But in a lot of cases, when you try to mix something like this, where you have two different versions of GCC being used, you get some explosions in the linker. And you're going to get some very, very funny errors, kind of like the one we see here, on a bunch of undefined references. That's your typical linker problem. I actually did an application, a very small application, and I saw 300 errors just in GCC incompatibilities like this. What's actually happening here is that when GCC revs its versions, it's changing the C++ ABI. So there's a problem that happens where you get ABI incompatibilities. And a lot of times the OS and the RTOS C and C++ versions are based on old GCC versions. OS and RTOS vendors are not experts in compilers. They're experts in operating systems. So they're not necessarily going to want to complete updating their GCC versions. Whereas AdaCore is a compiler vendor, we're compiler experts. So we're there to make sure that we provide the compiler expertise. So it kind of makes sense in this application to get your compiler tools from a compiler vendor and your OS tools from your OS vendor, instead of getting your compiler tools from your OS vendor. So in the case of Ada, C, and C++, it makes sense because we can match these GCC versions. If we supply all three compilers, you won't have any issues with any GCC versions because they're all going to be based on the same version of GCC. Where if you get the version from the OS and you try to mix that with the version from AdaCore, you could potentially have problems that are quite difficult to track down. In some cases, as I mentioned earlier, you might only have C and C++ in your application. Again, this is a time where it's potentially beneficial to have your C and C++ compilers provided by a compiler expert, and your OS, so your OS vendor can focus on their OS technology. A couple other interesting things you would see with the AdaCore C, C++, and Ada tools. If you've ever done a port of a processor, meaning you probably came from PowerPC and then transitioned to x86 or ARM, you will have noticed that the endian has changed. So this can potentially be a problem when you have structures that are overlaid on memory, because all of a sudden the memory layout's different. So with Ada, we can use a pragma called scalar storage order, which allows us to flip the layout of the record so that we don't have to do any manual byte flipping. If you use the AdaCore C and C++ compiler, you can also use the same pragma here. So you don't actually, any struct which is overlaid on some memory and is dependent on the layout of that memory, you're able to specify the endianness. So let's say, here's an example. Let's say you have some software which is bringing in some network packets. And those network packets are big endian, but your new processor is little endian. So all of a sudden you have a mismatch in your structs. And you're going to overlay these structs onto the packet stream. This would be a case where you'd want to specify the scalar storage order so that the compiler can automatically do all the byte flipping so that you don't have to do all of that manual work. You also have the ability to do exception propagation across boundaries of Ada. So this is kind of interesting because you might have some C++ libraries that you're using from Ada, and then you might even be calling that Ada from more C++. So let's say you have, again here, C++ calling Ada, calling C++. C++ throws an exception. Ada can catch that exception and re-raise it, and then that can be caught again in the C++. So having similar versions of GCC here is very important. The exception propagation mechanisms in the back end of the compilers change fairly often, which makes the ABIs incompatible. So if you are trying to do an application like this, it is very beneficial to make sure that you get your compilers from a single vendor so that you can verify the same versions of all the technology across the languages. And also, if there's any issues in this process, you can talk to the compiler experts. You can also import code. So the way the binding works between Ada and C or Ada and C++ is we do these things called pragma imports and pragma exports. So a pragma import is kind of like specifying something as extern in C, for instance. So what this does is this tells the compiler, hey, these are symbols, or these symbols are defined externally, and then the linker comes by and handles all of that, all of the linking. We can actually, if we do this in fairly complex structures, it's sometimes fairly easy to get wrong. Like for instance, at the top here, we have some convention, so we have some record, which has some convention C, and then we have the similar definition in C here. But you'll notice that we have a function, a void function in C that takes a variable of that type structure, but we didn't specify pass by copy in the top version. That means that it's going to be the structure might not be updated if you change it internally to the procedure. So this is kind of a thing where, if you don't actually know how this mechanism works in Ada versus C, this can be very easy to get wrong. So what's nice about using our compilers is we have the ability to automatically generate these bindings. So from C to Ada, we can use this switch when we call GCC called fdump Ada spec and specify the header files. That will generate Ada specs. And we can do the opposite. So if we have Ada specs and we want to generate header files, we can use the -gnat CEG switch. These are kind of nice because, again, you can have the compiler generate the bindings for you, and then you can go in and modify them if you need to. In many cases, I'll have the compiler generate the bindings, and then I will go in later and create a thicker layer over those bindings to make sure that I can use the interfaces without having to use, let's say, C types from Ada or use strange Ada looking types from C. So that's the kind of difference between a thin binding, which can be generated by the compiler, then you can build up a thick binding on the outside of that. So we talked a bit about Ada's interaction with C and C++, and there are some benefits to being able to use C and C++ compilers from the same vendor. Let's talk about introducing other languages with Ada. We talked about pragma import and pragma convention and pragma export a little bit for integration with C and C++, and we talked about a little bit about the automatic binding generation. But we can also actually interop with Java using the Aegis framework. This is kind of interesting. If you have a Java Ada application, you want to be able to run your Ada from Java, you can do that through the Aegis framework. We also have the ability to embed Python interpreters in Ada applications using the GNATcall library. So GNATPro is kind of a fairly large tool suite. Again, we talked a bit about all the benefits of the compilers. With those compilers, we also have GDB debuggers. You can do remote debugging on boards if you need to. You can use GDB remote. You have all the things you're used to with GDB. We didn't talk yet about the other tools that you have available within the GNATPro Toolsuite. So as you're going through your development, you might want to get some information about your code. For instance, let's say you want to know how many lines of code you have or what your cyclomatic complexity is in your code. You can use a tool called GNATmetrics, which is a basic static analysis tool. That allows you to compute all of these types of metrics about your code so that you know more about it. For instance, let's look at cyclomatic complexity. This is a number that's very useful for software managers to understand. It indicates how difficult it's going to be to test a specific section of code. So if you have a cyclomatic complexity that's very high in some area of code, it's probably going to be some sort of nested state machine or something like that, where in order to get full code coverage on that section of code, it's going to take a lot of work. Whereas if you have a lower cyclomatic complexity, it's probably much easier to get your code coverage because there's a lot less branches to test. So these are good numbers to know for software managers, even for developers. You might be thinking, well, what if I want to set maximums on these things? I want to make sure that my developers don't specify cyclomatic complexity over a certain number. Or let's say I want to make sure that the developers shouldn't use certain functions of the language. Or I want to make sure that my software is portable. You can use a tool called GNATCheck, which is a coding standard checker. So what we can do is we can take a coding standard and write a rule file. I'll show you an example of this in the demo. From that rule file, we can specify what rules we want to check on our source code. That allows us to make sure that we follow a specific coding standard. The GNAT-elim tool is a tool you can use to find dead code in your application. So what happens is that this tool, GNAT-elim, builds a static analysis tree of your source code and finds any nodes that aren't connected to the main run. So for instance, let's say you wrote some test procedures and you compile in your production mode. So those test procedures are just sitting there. Code gets generated for them, but there's no calls from the main application. GNAT-elim will say, hey, these are orphan nodes. We need to make sure that I need to report that these are dead. So this will generate what's called a pragma rule file that specifies where in your source code there are dead pieces of code. You can then pass that to the compiler, and the compiler will strip those from the final executable. There are cases where if you use GNAT-elim, you might want to verify the output of GNAT-elim. For instance, let's say you have an interrupt handler. That interrupt handler looks dead, so GNAT-elim will flag it and say this is dead because there's no call anywhere from the main application. So this is a case where you have to go in and say, hey, this is actually something I need in my application. Please don't strip that. You also have a tool to do unit testing. So if you are a group that does do unit testing, it's always nice to have some framework you can build on so that you don't have to write your own framework and drivers and all things like that in order to do all of your testing. We have a tool called GNAT-test, which is a tool which automates A-unit calls. So A-unit is kind of like a library. You might be familiar with JUnit from Java, something very similar. So GNAT-test automates generating test skeletons, drivers, and frameworks, and automates maintaining these. So what happens when you run GNAT-test on some source code, it will look at all of the specifications and generate test skeletons for those specifications. It won't generate the test itself. It'll just generate the skeletons. So that's nice because your developers can then go in and fill out the test skeletons without having to worry about what gets called from where and all that. That's all automated by GNAT-test. If you're doing a native application, we do have a tool called AWS. It's actually a library. Not to be confused with the other AWS. AWS stands for Ada Web Server. This allows you to do some basic HTTP type applications or SOAP applications on your application. So let's say you have a system where you have some Ada in the background and you want to talk to a user interface. What you can potentially do there is use a browser on your user interface, run AWS within your Ada code, and basically do a server-side application with the Ada, and then write a JavaScript front end, rather than having to do things in, let's say, Java or use an Ada binding to a graphics library. The next tool is called GNAT Emulator. This is a tool you might use to emulate some target. So this would be if you're cross-compiling. And let's say you don't have hardware and you want to be able to do some tests on that hardware, you can use GNAT Emulator to emulate the hardware and then run your tests on that emulation. The GNAT Stack tool is a tool that can do stack prediction. This is particularly useful in bare metal where you have a potentially very small stack specified. This is kind of a nice thing, and this actually works for Ada and C. We talked a little bit about Spark earlier. Spark is a subset of Ada where we've removed pointers. We actually have integrated pointers back in, but with some caveats there. So the basic idea of Spark is that if you remove, let's say, pointer aliasing, where you might have two pointers pointing at the same memory, that's an issue because if you free the memory from one pointer, you have a dangling pointer. So if we remove that feature, we basically have a language, which is a subset of Ada called Spark, and that allows us to do formal proofs on the code. So as I mentioned earlier, the Ada will introduce a lot of checks into the code to check to make sure there's correctness. With Spark, we can actually prove all of those checks statically rather than having those checks run at runtime. This is particularly useful if you have an application that needs to be small and fast, for let's say embedded, where you don't want the compiler-generated checks, but you still want to make sure that your code is correct. You can use Spark to prove a lot of these checks before you even run the code on your application, and then strip all of those checks out of your final binary. And again, these are all included with the GNATPro Toolsuite. So if you already have access to this GNATPro Toolsuite, you should have access to all of these tools so far. I have a question here about how to invoke GNAT-alim. If you go to if you already have access to the GNATPro tools and you have, let's say, GPS installed, you can go to the Help menu and then go to GNAT and then go to the GNATPro User's Guide and go to GNAT-alim, type in GNAT-alim in the search. I believe that should bring you to the how to actually run GNAT-alim in there. And once I get to the demo, I can show you where that is in the documentation. If you don't have GPS available or if you don't have GNATPro installed, you can go on our website, adacore.com, and then type in /documentation. That'll bring you to our main documentation site where you can go in and find all these documents. So if you were to go there and go to GNAT, you should be able to find the GNAT User's Guide available there. Some more things you might have available. I'm noticing I have GNAT-alim mentioned again here. Really like GNAT-alim, I guess. Another tool that's particularly useful is the GNAT-doc tool. This is a tool that's kind of like Doxygen. This allows you to create documentation from your source code. So the GNAT-doc tool reads your source code and then generates documentation. You can use Doxygen-like annotations to create extra documentation about, let's say, for instance, subprograms or types. There's a pretty printer included with the GNAT-pp tool. I mentioned the GNAT collection earlier, GNAT call, that included the ability to embed Python interpreters, but it also allows you to do things like SQL, email, a bunch of things that, a bunch of utility-type tools. This is available on our native platforms. GNAT-mem is also available on native. This allows you to look for potential memory leaks in your source code. GNAT-prep allows you to do source pre-processing. And the GPR build tool, for any of those who have already used GNATPro, this is the tool you always use to build. So this is I'm going to show you an example of this in the demo where we can have a project file and use GPR build, to read the project file and generate binaries. The main IDE, so the entry point for all of these tools, is called GPS, the GNAT Programming Studio. In the near future, you might see this change to just called GNAT Studio. This is very similar. This is a similar tool where it allows you to do your typical IDE type things. So this includes all of the compiler tools, all the tools we mentioned earlier. You can access all of those through nice menus. You can do navigate to references. You can generate documentation. You can do integrated debugging, so you can click for breakpoints and have memory viewers and all that available within the IDE. For those who like Eclipse, we do have a GNAT Bench plugin for Eclipse or for Wind River Workbench. This allows you to have access to all of these tools via the Eclipse interface. Another tool that might be interesting for software managers is a tool called GNAT Dashboard. So GNAT Dashboard is a tool that takes all the information generated by all of these GNATPro tools and dumps them into a single dashboard environment. So if you're looking at doing project management or development management, this is a tool that lets you know how you're doing or how your team is doing. So the GNAT dashboard is a plugin for the SonarQube dashboard. So if you're already using SonarQube, this is a tool that allows you to integrate all of the GNATPro information into that SonarQube dashboard. So that's everything included in GNATPro. I want to talk about a few other tools that we have available. I'm not going to go into too much detail about CodePeer because, as I mentioned, we will have a webinar on CodePeer specifically next Thursday. Information about that will be sent via email after after today's presentation. But CodePeer is an advanced static analysis tool. So as I mentioned earlier, so we have some basic static analysis tools that'll compute metrics and things like that. This is advanced. This allows you to check for runtime errors or logic errors in your source code. So think of this as a bug finder, a software quality tool, and a security analysis tool. This can find potential errors and potential security holes in your software. For those who have any security requirements, or security reporting requirements, CodePeer can generate security reports about your source code that your security teams can use to figure out the security vulnerabilities that exist in your code. I mentioned Spark Discovery earlier. Spark Pro is a pro version of that, and as I mentioned, it's kind of a programming language, so it's a subset of Ada. It's a verification tool set. That's the static analysis portion, and there's a design methodology, and those are the contracts I mentioned earlier for Ada 2012. You use all of that to generate software which can be completely absent of runtime errors. You can prove certain functional properties statically. You can do a lot of extra quality assurance with the Spark toolset. This is typical stuff you do during testing that you can prove statically using Spark. QGen is a tool that can take Simulink and generate Ada or C. So for those doing modeling, this is a tool we have to be able to generate Ada source code from Simulink or from those modeling blocks. The nice thing about QGen is that the output can be used in D0178 aviation applications. So for anyone doing safety critical applications or doing specifically D0178, which is the aviation certification, QGen is a tool you can use to generate code which can be used on your final target during for your D0178 application. So that's it for the presentation portion of this. I'm going to go into the demo next, where I'll actually show you a bit of some of these tools. For any questions that follow up after today's webinar, you can contact our account manager here, Philippa Bell, at bell@adacore.com, or you can visit our website at www.adacore.com. So I'll switch to the GNATPro tool here. Okay, so we should see an editor up here. What I have, this is GPS. This is the GNAT Programming Studio. And I have a project loaded into here. This project is fairly small. I assume most of you in the audience today have seen projects much, much bigger than this. But what's nice about what we're seeing here is that we're looking at some source code. We're looking at the project directory on the left. We can see an outline directory on the left. These are all things that you're used to in a modern IDE. What we see here in the left pane is the project file. This project file can be edited graphically. We don't have to write this sort of source code here. But if we want to do things that are particularly complex, we can actually write this by hand, and it kind of looks like Ada. So I'm going to increase the font here. Let me know if the font is still a bit too small. So what we see here is it looks like Ada. All we really need from the source file is just to know where the main is, what languages we're looking at, and where the source directories are. That allows the project to be loaded into GPS. You'll also notice on the left that there are check marks next to some of these next to some of these files, and there's these little green circles next to some of these files. This is actually the Git status. So we actually have Git integrated, certain Git functions integrated into GPS, and it allows you to view certain things about your version control. If I want to build this application, it's very easy. As I mentioned, the compilers and debuggers are integrated into the IDE. All I need to do is press the build, and that will run GPR build with the right switches here at the bottom. And that will generate an output file. So I could run this from this application now. What's interesting here is I also have access to all of these other static analysis tools. Like for instance, I mentioned GNATmetrics earlier. If I wanted to view the metrics about this project, I can right-click on the project, go to metrics, and I can compute the metrics for this project. I'm going to compute everything just for fun. That'll run GNATmetrics in the background, and that will generate this output file, which tells me a lot about my code. You'll notice that at the top, there's all the summary information, how many subprograms I have, how many lines, comment percentages, and things like that. We can also go into detail. If we wanted to see, for instance, this specification, we can actually view all the metrics for this specification, and we can view the metrics for the package, and we can view the metrics for each subprogram in that package. This allows us a very granular view of our application. If I wanted to check this application against a coding standard, I can generate a coding standard document like we see on the right here. So as you notice, I have some commands here, which is saying add a rule to make sure that we don't use any predefined numeric types, for instance, or make sure there's no exits from conditional loops, or make sure we don't use any go-tos. That one's kind of obvious. But what I can do is I can run GNAT check against this application. So as you notice here, now at the bottom, I have a bunch of checks. As you can see, I'm using anonymous types. According to my coding standard, I shouldn't be doing that. As you can see here, I have some explicit references. I have things like, anonymous subtypes again. I have positional parameters. So here I should be, instead of using positional parameters in a function call, I should be using named parameters. These are all interesting things that I can do with the coding standard checker. I also have access to Spark here. So with your GNATPro installation, you do have access to Spark Discovery, which is a light version of Spark, Spark Pro, sorry. Spark Pro allows you to do a lot more proof, a lot more extra work that you might need to do, let's say, full functional correctness of code or complete absence of runtime errors. With Spark Discovery, though, you can still do some basic analysis, which will allow you to make sure that you don't have any flow issues. So, for instance, make sure that you have, let's say, an if statement, and that if statement can always evaluate both true and false. For instance, if let's say you don't have a dead branch in, let's say, a conditional check, or let's say you have a loop and you want to check to make sure that loop can actually exit. The Spark Discovery tool can do that sort of analysis. And if we wanted to debug this application, I could actually start off a debugger here. And you'll notice that I get access to a GDB console here. But I could also specify breakpoints physically here. So I could actually do the same if I were to type right in the GDB console. I have access to data windows, like for instance, I can view memory, I can view the assembly, I can view registers, things like that. All the things you're used to with an integrated debugger. And again, all this is really doing is automating calls to GDB. So for now, I'm going to exit the GDB process here. So before I mention where you can find documentation within GPS, I know some of you might have applications where you might be working on machines that are air-gapped, whether you're in, let's say, some labs or something like that, or you might not want to have to call out to the internet every time you want to get documentation for our tool set. You can actually access that documentation by going to the Help tab here, and then you can access all of our documentation. So for instance, I mentioned earlier the GNAT User's Guide for Native Platforms. This is going to open a local copy of the user's guide here, you'll notice this is installed on my machine. And if I wanted to, let's say, view the GNAT-LM documentation, let's jump to that here. So we have a section here about doing elimination. So if we were to scroll down a little bit in this document, there's the GNAT-LM tool right here. So unfortunately, the GNAT-LM tool, I know I had a question earlier about how to invoke it. That's a command line only tool that hasn't been integrated into GPS yet. But if I were in GPS, I can actually go to the window or the view here and open up an OS shell. So if I did want to access the GNAT-LM tool, I could do, oops. I could do something like that, and I have access to all the tool sets here. What's nice about GPS is that we tried to integrate as many of these windows as possible, so you only really have to look at one thing. And I know a lot of people are still using, for instance, I still use the command line very heavily in my development process. So I like to have the development window or the command line window here at the bottom. So I think I'm going to go to the questions here. I'm going to stop sharing my screen. Moment. Oh, Q&A. Here we go. Okay, we have a question here. When will a working version of the GNAT-Purdy printer be released? So the background to this question, the Purdy printer we actually have two Purdy printers. There's the GNAT-PP tool, which I can call from the command line here. That sometimes has issues with certain structures inside the code and isn't as configurable as some people would like, and it's actually quite an old tool. What we're doing is we're rewriting a lot of these tools that I mentioned today. The background to that is GPS is built on top of the compiler. So the compiler generates the analysis nodes that GPS uses to do its analysis. So for GNAT-PP, it actually requires the compiler to be present and running, and your source code to be compilable. So this is kind of a problem in some cases because you might want to pre-print something that is either not syntactically correct yet, or you might have some, let's say, source pre-processing or something like that in your Purdy printer or in your source code. So using the compiler version was a problem. We're rewriting all of this to use what's called the libadalang toolset. So you might be familiar with clang. That's a tool that's used within LLVM that allows you to do some static analysis type work. We're doing an equivalent for Ada called libadalang. That allows us to do static analysis without a compiler present. So what we can do is we can rewrite the GNAT-PP tool, the GNAT-metrics, the GNAT-doc tool, all of these tools so that they don't have to rely on a compiler. This also will make them a lot more flexible and a lot more customizable. So these are things that are going to be released within the 20 version next year and the following few years. So basically, it's a complete rewrite of a lot of the back end of our tools. And again, that's going to allow you to do a lot more complex analysis, a lot more complex Purdy printing, a lot more complex coding standard checking, things like that. And it's also going to allow you to do some customizable work. So right now, I think in GNATPro 2020, the new reference engine is going to be done with libadalang. So for now, let's say I'm in my source code here, and I want to, let's say, see the definition of this open subprogram. I can either control-click or I can right-click and go to declaration. The way that's currently computed in GNATPro 19 is it's done via the compiler. So you actually have to compile your code first. and that's a major annoyance because it's your code might not be finished. You might be doing some work, but you still want to see this definition. Within the 2020 version, that's going to be done via libetalang and will not require a compilation, which will allow you to do cross-referencing and generation of various call paths and things like that without the compiler. For instance, I'll show you the call path here. If I'm in this is the main procedure for the application. This is the entry point. I can right-click on that, go to the browsers, and I can actually look to see what this calls. So I'm going to do a recursive. What does this call 100 times? Let's say my application is very small, so that's overkill. I'll do that, and that'll actually generate. A call graph. This shows me exactly what calls what, so that I know, where things are placed in my application and how I might want to refactor some things. I have another question here. Is there a plan to add C++ support for the developer license? So that question relates to our product tiers. So we have 3 different product tiers. One's called GNATPro Assurance, one's called GNATPro Enterprise, and one's called GNATPro Developer. The main difference between them is how we perform support and how we deliver products. So in the GNATPro Assurance toolset, we can provide safety critical and assurance critical fixes to versions of technology that won't completely change the compiler. So this is an instance where you might have certification and the certified compiler is frozen because of the certification. So GNATPro Assurance allows you to get new versions or get updates or fixes to compilers and tools with all the documentation necessary so that you don't have to go through a recertification with your software. The GNATPro Enterprise toolset is our kind of our standard toolset. This includes support that's done within 2 business days. That means you'll have a guaranteed answer, guaranteed response to your question within 2 business days. Usually this is much faster. For anyone who already knows us, you probably have gotten responses within a few hours. And all the support in GNATPro Enterprise is done confidentially, meaning that other accounts, other developers outside of your team can't see the questions and responses that you're asking. With the GNATPro Developer Toolset, this is a limited set of tools with a 5-day response to questions, and those questions are done in a public fashion. So this is a case where you might have some teams that are new to Ada and are, let's say, working on a prototype or bringing up products and want to be able to do some work without before they scale, for instance. So let's say you have a team of a few developers that are working. This is a good time you might want to use Developer to kind of get started and then move to, let's say, the GNATPro Enterprise toolset once you scale. So the original question, is there a plan to add C++ support for the developer license? That's a good question. I'm going to take that and then respond directly after the webinar today. I'll check with our product managers to see what the plans are, and then I'll get a response to you after the webinar. Currently, the GNATPro Developer Toolset comes with Ada and C. So in most applications, most embedded applications, that's a typically good toolset. But for more advanced developers, C++ might be necessary. So again, I'll respond after the webinar, after talking to our product managers. We have 3 more minutes remaining. If anyone has any other questions, I'll hang on for 3 more minutes. For anyone else, thank you so much for attending. I really appreciate everyone hanging out today and learning more about GNATPro. If after the webinar, you'll receive an email with the recording. And you also have information about the next webinar we'll have, which is next Thursday, about our CodePeer tool, which is an advanced static analysis tool. And it allows you to do things like check for runtime, check for errors in your code before you even get to testing. So I think there might be a question about pre and post conditions that came up. The question is it worth introducing pre and post conditions progressively? And the answer is yes, definitely. If you can use Ada 2012, you don't have to change any of your source code, just change the compiler. If it compiles without any problems, now you have the ability to introduce, let's say, pre and post conditions as you feel you need them. So this is the case where you might have a section of your code which is critical, where you might say, let's say this section here does something that's doing some encryption or something that is doing something super safety critical. I want to make sure that this is being called correctly, and I want to make sure that the implementation follows some sort of specification. You can put these contracts on one or two subprograms just to start. And then once you have those once you go through the process of introducing those contracts, you can start to spread them as you see fit. It's definitely not an all or nothing thing. You can definitely add them one at a time. What's interesting though, with our tool set, even if you're using Ada 95, there is a way to still use pre and post conditions with the GNATPro compiler. There's a Pragma version. So if you go to our documentation, go to the GNAT reference manual, look up Pragma precondition and Pragma postcondition. That'll allow you to do contracts for Ada 95 compatible code, for instance. So if you have any more questions for us, you can go on our website, adacore.com, and you can go to the Contact Us page and send all of your questions there. We'll follow up as soon as we can. And also look out for an email after this presentation for a link to the recording and for information about next week's webinar. Thank you very much.